A new astrobiology study has identified a supernova that occurred 2.6 million years ago. And it's fascinating because it just might have had a profound influence on earthly evolution. Now, on an astronomical timescale, 2.6 million years ago might as well be last week. It's pretty recent. The star that exploded was also about 160 light years away. And for us humans, on our little tiny human scale, 160 light years is an insurmountably huge distance. But again, astronomically speaking, it's not that far at all. In terms of our galaxy, this supernova happened right next door. Despite its proximity, the Earth itself wasn't actually too badly damaged by the supernova. Our little blue planet was hit by the radiation and the ejected material, but it didn't totally destroy our atmosphere or boil away all life on the surface. But it did happen to coincide with the Pliocene-Pleistocene extinction event, or the end-Pliocene extinction, where nearly a third of large marine animals were wiped out. Among these extinct marine megafauna presumably killed off by the supernova was the Megalodon. If you haven't heard of the Megalodon, it was an absolutely enormous predatory shark with huge jaws. On a side note, the Megalodon is the big bad monster creature in the recent Jason Statham movie called The Meg. Alright, but back to the study in question. There was another event that happened 2.6 million years ago. The Earth experienced a magnetic pole reversal. These pole reversals happen occasionally, and when they do, the Earth's magnetic field is weakened for a short period of time. Short from a geological perspective. The reversal process can take centuries, so there's a window of time where the Earth is more vulnerable to radiation. Alright, so what's going on here? I'll let the lead professor of this research explain his hypothesis. Adrian Malott is a professor of physics and astronomy at the University of Kansas. He explained that life on the surface is exposed to stuff like UV radiation, and thus, surface life has evolved protections against radiation, like the pigments in your skin. Life on the surface is also exposed to muons, which can be tolerated in low doses. In contrast, life in the ocean doesn't really need to evolve a defense against radiation, because the ocean water itself is a perfectly good radiation shield. So when the supernova happened, the Earth was saturated with muons. The atmosphere became thick with muon interference, and life on the surface, even with its resistance to radiation, would have still suffered a significant rise in cancers and genetic mutations. And we can't forget the pole reversal that weakened the Earth's shield from radiation and cosmic rays. Malott said, quote, "The magnetic reversal would increase the muon exposure. Normally, cosmic rays of low energy are diverted by the magnetic field and mostly come down near the poles. But if you have a magnetic reversal, they impact all over the place." Unquote. When talking about life in the oceans, Mr. Malott said, quote, "Normally, below a few meters, water really shields a lot of radiation, but it wouldn't shield the muons. Creatures that are used to being almost isolated from radiation would suddenly get a whole lot. They would be unlikely to have as good of a defense against radiation as land creatures would." Unquote. Essentially, Mr. Malott's hypothesis is that muons from the supernova hit the Earth during the pole reversal, when the magnetic field was weak and life on Earth was vulnerable, so it caused undue damage to Earth life and played a critical role in the end Pliocene extinction. The muons are able to pass completely through the ocean, so the water wasn't an effective shield against them, and the surge of muons ended up killing a lot of marine life. The Megalodon is perhaps the most famous victim of this extinction event, and if Mr. Malott's hypothesis is correct, this massive, terrifying apex predator would have been killed off by a supernova. That's pretty intense, and it seems pretty fitting for the Megalodon, but the hypothesis doesn't just end there. Mr. Malott and his research team are trying to understand the full extent of the supernova, and the full extent of the end Pliocene extinction. His previous work has led him to suggest that the supernova may have had a larger impact on the planet's climate. By bombarding the atmosphere with cosmic rays, electrons would have been knocked off of the atoms in the atmosphere, like nitrogen and oxygen. And this, the electrons being knocked off of these atoms, this would induce heavy lightning. He's hypothesized that this heavy lightning would lead to a rise in forest fires, as lightning is a major cause of forest fires. These forest fires would have led to mass deforestation, and believe it or not, the data suggests that 2.6 million years ago, Africa experienced a rapid decline in its vegetation. Its forests quickly receded, and were just as quickly replaced by grasslands that blossomed out from the charred ash of the burned-out forests. This environmental change is actually what spurred human ancestors to descend from the trees and begin walking along the plains of Africa. This was a critical step in our evolution, and it led to us standing fully upright and spreading out of Africa and establishing modern civilizations. If Mr. Malot's hypothesis is substantiated with further research, then it's possible that the supernova that wiped out the Megalodon was also responsible for creating the environmental conditions in which modern humans evolved. If this is true, it's absolutely incredible. Our planet's evolution, and our evolution as a species, was profoundly affected by a distant supernova. This is really cool, because it shows how interconnected everything is, even on a cosmic scale. And it's also incredibly terrifying, because it could always happen again. I mean, you want to talk about a bad day. Imagine, on top of climate change, a supernova becomes visible in the sky for months on end, and its cosmic rays colliding with the atoms in the atmosphere cause it to glow an electric blue, day and night, and this causes lightning to cascade down on the Earth, as if Zeus himself was trying to wipe us out once and for all. This is just really interesting and really incredible stuff, and it's a great reminder of how integrated we are into the cosmos, and how all life on Earth is really at the mercy of the powerful cosmic forces that surround us.